Hello, folks. I see we have a few viewers tuned in. How are you all doing? I hope you're all doing well. So we'll give it a few minutes for people to come in, and then we will start. So we will wait a moment, and then we'll get to sharing. Hi, Michael. Hi, Nam. Just waiting for some folks to tune in here. Cool. So we'll get started one moment. I know a lot of people are going to be watching this, tuning in a bit later, but that's going to be all okay. Cool. All right, I'm going to run one test on the code I have working. I'm going to put the repo in chat, and I'm just going to push a quick update to it. Job tracker GSDC workshop. Alrighty, so Go doesn't have async or await, but we'll talk a bit about how we're going to be doing the functions. There is asynchronous stuff in Go, but we don't need to use it because we're going to be writing things just in a bit of raw HTML. So let me just Check this out here. Just making some improvements before this workshop, and I kind of broke a few things, so we're just gonna do that. So what I'm gonna do is share this repo in chat, and I'll make sure everyone can see it. So I'm just gonna be pushing a quick update right now to it, but make sure you follow along with what we're doing. It might not be 100% exact because we're gonna be starting from scratch, but it'll be a good starting point to base things off at. Okay. Fantastic. Okay. Great. So great. So what I'm going to do here is I'm going to open a new VS Code, and we're going to start from scratch. So I'm going to share my screen right now. We're going to get started. If you folks want to launch your editor and follow along, we're going to be starting very plainly, and you can ask questions as we go along. We're going to be making this all from scratch, getting this built. So you folks should see. Let's see if I can. There you go. Put my head in the corner. Great. So we right now have a new editor with nothing open. What I'm going to do is the first thing I'm going to do is I'm going to go to open a folder. And I'm going to go to wherever you want to make this file. So I'm going to go to my dev folder that I have. I'm going to make something called job tracker. And we're going to use this folder blank right here to start off with. Very simple. Great. So the first thing I'm going to put into this is it's going to be a README. And what we're going to say is this is going to basically have we're in README.md for the markup. And we're going to call this our job tracking app. Let me zoom in a few times here for you. So the first thing that we're going to do is we're going to build JSON REST API in Go. Then we're going to build the app with Docker. Then we're going to extend the app with database persistence, and that is with Postgres. And then we're going to plus Docker compose so we can launch them together. Then we're going to build a small front end for our app. Great. So plain simple, this is what we're going to be making today. So as well as a part of this, what we're going to want to do is you'll want to probably open your terminal. Make sure you have Git installed, so you can do, I think, Git version. You see we have Git installed. And we're going to want to make a new GitHub repository. So let's swap over to GitHub, and let's see how we make a GitHub repository. Great. So you open up GitHub and ensure you're logged in. You can go either to the top right, go new repository, or on the left, you can also go to new repository. What we're going to do, we'll name this one job tracker, and you can make it public, private, and add anything you'd like to start off with, but we already have a README in mind, so I'll just make it empty. What we're going to do is you can either use some of their commands to create the new repo or push an existing one. I'm going to use to push the existing one, so I'm going to press this copy button, and let's switch back to VS Code. Great, and we're back into VS Code. So I'm going to do git init, and it's going to make an empty git repository. I'm going to run git add -a, git commit -m init commit. Cool. I'm going to do git checkout -b main. We'll switch to the main branch. And then we're going to push everything up to main. So now we have our Git repository working and saved to GitHub, which is going to be critical for building up this app. So now we're going to start developing a bit. So we're going to make our first file, which is going to be our main.go file. We're going to make it as a normal Go file, and you can do this by doing package main, and then func main, and you can just do func.println hello world. Great. Func is imported automatically if you have the right tools. Otherwise, you put the import statement at the top. Let's test this works. We'll do go run dot. Cannot find main module. But found. So go mod init to make our go mod, and we'll call this. So you want to call your go mod. So go mod init, and you want to do github.com/ for me it's Alan Kaplan /job tracker is the name of the mod. And to generate the sums that go with it, you can do go mod tidy. So now we can do go run dot with the go mod file, and you can see it prints out hello world. Pretty straightforward at getting started with this app. So we're going to make a make file, and this is going to help us in the app to keep things like the commands that we're going to run very consistent throughout the whole of the app. So the first one that we're going to do, just like you folks saw, is very similar. We're going to do go build. It's going to be go build -o app and then dot. And then we're going to just do go run. And what it's going to do, we want to execute go build, and then we want to execute dot/app. What I'm going to do is I'm going to make a .git ignore file as well. And in this, we're also going to put app, which is the binary file that we're going to create. So Go, unlike other languages, compiles down into a binary. So with that in mind, we're going to need to, with compiling into a binary in mind, we're going to need to do that every time we want to basically run it. So now we can do make go run, and it'll run make go build as well. And you'll see the same thing. It'll build the app, it'll run it, and you can see hello world. Very straightforward. And we can see app appears in our directory. So let's start fleshing out a bit of the app. So the first thing that we're going to want to do is we're going to want to bring in our HTTP router and start working with that. So to get our HTTP router working, we're going to want to bring in a tool called Gin, which can be done by doing go get github.com/gin gonic/gin. I already have it. It's not going to do much for me, but it's going to go get it. Because the next thing we're going to do is we're going to test out making a quick server. So we're going to say, we'll make this one starting job tracker. Yeah, so the Go has its own compiler with, and it's just like GCC, exactly, NAM. So what we're going to do now is we're going to create a router, and it's going to be the default gin router. Go doesn't know what the hell gin is, so we're going to need to bring it in as an import, which is why we did go get. So we'll import github.com/gin gonic/gin. If you use some editors, it can do this automatically, and it's telling me there's an error. No module provided. I don't use VS Code this much, but it does usually work, and we can see that we have gin over here as our requirement. So the error goes away with gin being indexed, and we can see that we have router. Go needs it to be used, so the first thing we're going to do is we're going to just have it run, and so we're going to do router.run, and we're just going to run it on port for now 8080. Cool, but that doesn't really do much. So let's get the first thing. Funct is a standard library package winterbear. So the standard library of Go has a lot of things in it. So we can see the definition of Funct, and we can see everything in it. I understand it's kind of big on my screen because I zoomed in, but it's a standard library package, meaning that everyone who has Go has the Funct library, as well as other libraries like errors or net HTTP, which is underlying Gin itself. So the next thing we're going to do is we're going to add our first endpoint to our router, and it's going to be /ping, which will let us ping it. And we're going to it's going to take in the handler, so what's going to be called when someone hits the endpoint, and we're going to call it ping handler. Let's go and define ping handler right below. We're going to say func ping handler. It's going to take in the Gin context, and let's have it return JSON with c.json, return status code 200, or I think you have http dot code status. I think okay. And then we can return just some simple JSON with a gin.h message pong. So now when we hit ping, we should get pong. So let's do make go run. We can see it's running in development with the Gin router. Let's curl localhost 8080/ping, and we can see we get back message pong. So right now we already have a working HTTP JSON REST API, which is fantastic to see. So talking about a job tracker, we need to think of what are our data models. So let's go ahead and put a file. Let's call it for now applications.go. And this is going to be for our job applications. We'll put this in package main because we don't really need any deep package structures with this project. And we're going to think, well, what is our data model for a job application? Maybe if you folks in chat want to tell me, what do you find to be the data models that would be involved in job applications? So we're going to first define the application as a struct. That is something with fields, or if you've done Java or C, very similar to some sort of object or type def in C. To me, what comes to mind when I think of a job application is usually the company I'm applying to, which is a string. We have a position that I apply to, because sometimes I apply to multiple positions in different companies. I usually want to keep track of the link that I'm applying to. I want the status of the job application. And it's generally good to have a date when I last updated. And we can use a time.time. So putting this all together, we can see an application is the company, position, link, status, and its last updated time. When thinking of how we're going to use a database, we're probably going to want something like ID. And we can make ID pretty simple. We can have it just be int. So that's pretty great and all, but we also need to return JSON at some point. So what I'm going to do is, if you right-click in VS Code, you can do add tags to struct. And so what we're going to do is add tags to struct field. And this will generate this JSON tagging for us, which is going to be quite useful. So let's kind of see how this works. Let's make another endpoint. We'll call it router.get. We'll make it /app and ID. So let's say we want to get a specific application by ID. We'll call this getApp by ID, which is our handler. Let's define it just like our ping function. Func getApp by ID takes in the C or the context, and we're going to have it return something similar. Let's define an application as an application, and we need to put in all of its definitions. So we have an ID, we're going to use the, we'll actually do this here because it's an int. We're going to say ID is going to be C dot params, and it's going to be the ID parameter, which is right up here. But this doesn't go because it is an int. So we'll just need to make sure we do string conversion, parse int in base 10, 64-bit, so we can get an ID. That is what we want. Great. And just like everything else, we'll need to make sure we bring in string conversion here. Cannot call params, didn't type params. Pretty sure I can. Let's look at the documentation. You know, things aren't always smooth when coding, but generally should be. So get app should come from here. C dot find, what is it? C dot param. Oh, okay, C dot param. I hope so. Okay, it was C dot param. I was just tripping a bit. Okay, great. So we'll add in some more stuff to that. We still have our company. We still have our position. We have our link, and then we have our last updated, I believe we called it. Great. Let's zoom out a bit. Last updated. So company, let's make it something simple. Let's go Google, position, software engineer, link, google.com, that's where I would apply. And then, of course, our last updated, let's just put time.now. And let's just do a nice int conversion. So for those who don't know, the default int in Go will be 32 or 64, depending on the system type. So sometimes when you're converting, you don't really know. All right. Why is there an underscore behind ID? So yeah, parse int returns an error, as you can see being highlighted here. Returns int64 an error. So we're not going to handle the error assuming things. If we want to handle the error, we can check error manually, and we can say if error is not equal to nil, and we can return, or not return, we can rather see abort with error, and we can say http.status internal server error. And then we can just pass it the error. So this way, maybe you send in a malformed ID, and we'll actually be handling that case now. And we'll tell people that it's an internal server error. So now we have an application, and let's say we want to return it. We'll just do a c.json back with http status OK, which is standard. And what we're going to return, we're going to send it app. Cool. So this is the get app by ID, and it will return an app with the ID we specified for now. We're going to make this a bit more elegant soon by actually introducing a place to store them. And we're going to start with just a simple slice, and then we're going to make it into a database. So let's, for now, do make go run the app. Cool. And let's go to curl app/2 returns something empty. Interesting. So I see that I'm running more than one of these apps. Make sure that this is exiting. I'm going to switch over to using Docker soon. It helps deal with these issues. No? Okay, cool. So you can also do make, or you can always do go run dot. The annoying thing is on Windows, if you realize every time you do go run dot, it might do this. So it says listening, find only one instance of each socket is normally permitted. So as if there's something else running on the socket, which makes me think that something else is running somewhere. Perhaps I'm still running my Docker container, which definitely could be it. Let me just do Docker compose down in another terminal. Okay, great. So, okay, and here we can see things are running normally. So listening on port 8080. Great. So we can see things are running fine, and we can see the logs. We'll open up a new terminal. And in this terminal, what we're going to do is we're going to do curl localhost 8080/app/2, and you can see we get returned the JSON of the equivalent of the object we just put in here. So if you were using any front end like React, Vue, or even just plain JavaScript, you'd be able to parse this JSON immediately and be able to start working with it, which is great to see. But really, we don't want to return the same application every time. So let's start with something basic, and we'll just create a general variable that we can keep. And we're going to call it applications. We'll make it global, and it'll be a map of string, or rather int, to application. And this represents kind of a database where you have a primary key of ID and the object of database. And we're going to improve this a bit later. But let's start with this. So let's get applications initialized, and we'll make it make map int to application. So it's kind of like the new in other languages, and we're going to get that done here. Applications, not expression. Oh, because so this is applications. Great. Let's call this apps for short, because I don't want to have to type applications all the time. Great. So let's create another func, because at some point we're going to need to create things, right? So let's define another endpoint, and it's going to be a post endpoint, so we can send some data with it. We're going to go to router.post. We're going to give it /app, and we're going to do create app. So just so you see, we can post, and we're going to do create app, but we still need to define it. So let's go to func. We'll call it create app. It's going to take in the gin context, so we can make it a handler. And now we're going to do something different. We're going to first define our var app as application. Then we're going to use the quick gin binding. So what we're going to do is we're going to bind an incoming post response body to this application. So let's bind it. And so when someone now sends us an application JSON, we're going to be able to put that into a Go model to deal with. And then we can say something like apps app.id equals app. And then we can do c.json http.status. Okay. And let's just return it back app. So we can see it was at, like, say, okay, we added it. So pretty straightforward. And so if we go to our current curling, it might be a bit difficult to do more complex expressions. A tool a lot of people use is Postman, and what we're going to use is a similar tool. So, so there's a tool that used to be called post woman, and we're going to be using what it's become, which is now called hopscotch. And so hopscotch IO, which I'm putting in chat right now, is how we can make requests to our backend. Just trying to find the StreamYard tab. Excellent. And so at hopscotch, we'll be able to send some requests. So I'm going to update my shared screen really quickly, and let's share a bit more. So I have a bit of a wide screen, so let's see how this comes out looking like. Okay, so let's see how this will come out to be. So we're going to put in localhost 8080. We'll try out ping first thing, and we'll rerun our app. So go to the original terminal. Exit out with Control-C. Make go run. Great. So we can see it's running. We'll send the ping. And we can see that we get the request in. Great. Cool, 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 cool. So we can see localhost 8080, we get it. It says cannot send request, but we do get it. Get. I'm just trying to see why it might not be. I use Postman. We might have to use Postman, but we'll see if we can get this going. Unable to reach API endpoint. Turn on proxy interceptor and try again. Could not send it. Interesting. I'm not sure why it's not running, because maybe it hates us. So we'll use Postman directly. So maybe it'll work for you. I've used hopscotch in the past, and it's been fine running to hit my local endpoints from my web browser. But I guess it's not able to do it. Shit happens. So we're going to run Postman. I just type Postman engine open. So I use Postman usually every day to test out other development I'm doing. It's pretty versatile for making sure you can run all your HTTP endpoints. So I'll show you a bit how to use Postman if hopscotch isn't going to work with me right now. You know, that's how it goes sometimes. So we'll open up Postman. Takes a second to start up. That's why I want to use an in-web browser one. It's a bit bulkier. So for folks who aren't familiar, Postman is just a way to manage your API requests. So I'll go and we will use a different workspace. So this is obviously a project that I work on almost every day now. And we're just going to my workspace. Cool. So let's create a new request to localhost 8080/ping. And we get back message Pong. See, everything's working just as it should. Let's try and get app 2, and we get our app number 2. Everything's working very smoothly. Now let's try posting. So posting means sending a body. So I'm going to copy the response from the get, switch over to, let's actually make a new tab. Then we'll go to post localhost 8080, so to send some data. Send it to the /app endpoint. Send it some raw of type JSON. Paste this in. Give it an ID of 1. Call it Coinbase. That is where I work. And last updated, we can give it a time like this for now, and it should parse. So we send it, and we get it back. That's amazing. And if we go to app and we go to get, we're returning the same thing still, the static application. So let's do a few different things here. let's do this first. Let's go to C dot last updated. Sorry, not C, app dot last updated. And we're going to kind of take over and we're going to set that to time dot now. We're also going to take app dot ID. And for now, let's just make it a random int. So math, it's going to be math dot rand. And let's just give it a random number, 1 to 1000. And just math needs to be imported. So let me save it. Should import. Great. And it's imported after a bit of time, I hope. I'll do it on my own. So now we're kind of hijacking it. And we're going to send back app, but app will have a different ID attached to it. So we'll restart our app. Math.rand. Oh, I see. It comes from math/rand. And that is where the rand package is within math. So you got to make sure you import math/rand. And that way you should be able to do rand, I believe, dot, wait for it to load, int. And so we'll generate a random int, you know. I usually use UUIDs, but we're going to stick with ints right now. And we'll make it up to 10,000 by multiplying. Again, we're going to run make go run, restart the app. And it works fine. We'll make one more change really quickly. We'll comment this code out. And now let's actually return an application. We're going to go app OK, and it's going to come from apps. We're going to pass it ID, and then we're going to say if not OK, meaning if it doesn't exist in the map, return c.json. We're going to return http.status internal server error, and we're going to just return actually let's do JSON. Let's do dot error abort with status, abort with error, and then we'll just do errors.new, and we'll just say app does not exist in map. And no, I'm just not. I just could not get app from map. And this will import in errors. And so now we have app still. Let's move this if later so it can do it. We'll say if not OK. Says it can't take in that because this needs to be casted. And this should be fine right now. So now if we rerun make go run, and we send this post request, we can see we get back a crazy ID with the last updated time. Now let's get app1, and we're only getting back right now the last updated interesting time, meaning that could not get app from map. So there was some issue. Because that's not the ID, because I'm a bit crazy, I need to use the ID here. So yeah, sometimes the app works and you just don't. And we see we actually get the correct one back. Coinbase software engineer link and last updated, which is pretty awesome. Cool. We also will probably want a way to update our apps. So we'll do router.put /app/ID. We're going to call this update app by ID. We're going to take this out for now. And we're going to define our new function, func update app by ID, taking a C, gin.context. We're going to now we need to take in an app, but it won't have its ID will be the one that we're now updating. So we're going to do the same thing we did above. Var app application c.bind the app in. And now what we're going to do is we're still going to do app.lastUpdated equals time.now. But what we're also going to do is we're going to say app.id equals app.id. So now, or equals app. So now the app that is coming in will be the one changing that we will want to change. And so assuming that, this is intended, that, you can completely change any app that's coming in. And so then we'll just see .json back, app itself that was sent, and we'll make sure it http.status. Okay. So let's test this works out. And we don't even need this ID here because we're sending it itself. So this is a type of a put request, and put is used for updating for folks who might not have learned that, which is totally normal and okay. So we'll start this up. We see it runs. We're going to remove this because we know we don't need it. So we'll upload our new job application to Coinbase. And this is what's coming back. Because I sent malform JSON, let's send it again. Great, we get this ID, which is also, I guess, an int. I don't know how this int occurred, to be honest, but it is what it is. It should only return random that are above. So let's get this. We get it. Now let's create our next. But the code is kind of hard to read. It's blurry. No worries. Let me try shrinking the size down a bit of what I'm casting. You folks can let me know if you need to see the requests being made. Cool. All right, hopefully that looks better. Great. So what we're going to do is we're going to make our put request. And so I'll switch my screen to make the put request. So over here we have Postman. Let's make the put request. So we'll put localhost 8080/app. And in the body, it's going to be similar. We're going to send raw data of type JSON. So we're just going to send some JSON data. What we're going to do is we're going to send this, but let's send it a bit differently now. Let's say I'm going to now apply for front-end engineer. With this ID, we'll send this put request. We'll make sure it's formatted correctly. We get it back, front-end engineer. And now let's go get it again. And we can see it's updated. So now not only did we create something in our backend, we were able to update it and retrieve it. So we're able to do a lot, which is fantastic. And the last thing we really need to do is delete something. So let's go implement the delete code. So now we can do router.delete/app, delete app by ID. Since delete comes in with a body, we're going to only take in an ID. So now let's go func delete app by ID, c gen.context. We're going to say var ID int. We're going to go c.bind ID. Then we're going to say delete, and we're using a default go delete function, so it's in Go, and the key itself is going to be ID. Great, and then we can do c.json and we can do status http.status. Okay. And then what we can just return is gin.h, which is just going to be a message, and we'll say deleted. So let's use a funct.sprintf for this. Rather, we'll just say @% deleted ID. Cool. And this way we can just print it out like that. So let's try this out. Make go run. Let's switch over to Postman, and let's see how we are able to do. So I will post a new job, get its ID, query it. We can see it exists. Now we'll make a new request, a delete request to localhost 8080/app. In the body, we're going to send some raw JSON. It's going to be ID, like that. Send. We get app0 deleted. So obviously something kind of happened where things didn't bind right. So we're going to go fix that by creating a custom request type. So sometimes when you're developing, you might have lots of different types that you're working with, and your requests will need to return some composite thing. So what we're going to do is we're going to, in this function, define request as a struct. We're going to say it's of type ID int, and we'll just say, we can use our auto generator here, but it's ID omit empty. And now we're going to bind request, let's call it rec, by saying var rec request. And then what we're going to do is do rec.id. And so this way we create a custom request and response type that we're going to be consistently using. So let's rerun this and check if our new custom request type is going to help us solve an issue of a unique input, which only really appears at request or response time. So again, we'll post. Oh, unidentified ID, online 71. Okay, I think sometimes 76 ID. Okay, rec.id. Sometimes, you refactor code, make changes. So let's send this post request, and we get back the job. We're able to query it and see, and we're even able to delete it. And we can see app deleted. And now if we query it, we get we get this error, 500 internal status error, which is exactly what we wanted, because obviously it didn't work to get the app, so we got abort with error. And then there's an error in our console written out. So this is all well and good. We're able to create applications, edit them, delete them. We really have something working here. So now let's take this application to the next level by starting to run it in a Docker container. And it's going to be really critical that we can get it working with Docker, because this will let us use Docker Compose with Postgres to easily get a managed database version of it working. So let's swap back to VS Code. Great. So we're back in VS Code now. And what we're going to want to do is Dockerize this application. I'm not a crazy person for writing the code out from scratch. So what I'm going to ask is you folks take the Docker file I'm writing and copy it. But we're going to go through and make sure everyone understands what's happening. So I'm going to create a new file called a Docker file, and this is how Docker is going to be managed. So like I put earlier in chat, please make sure you're able to go to this repo, and it's going to show on screen now as well. It'll be in the description of the video for our folks who are joining us after this event. But please go to github.com, Alan Kaplan, and make sure you go to this so you can go get the latest Docker file. So the first part of our Docker file will really be building out the base of the file. We're going to use a Docker build kit when we do this. So as well, I'd suggest make sure you're using a shell that can take environment variables on the same line, like git bash. So we're going to start pretty simply, and we're going to say from golang latest as base, so the base of our container. We're first going to set our work directory to source. We're then going to make sure that we're not using cgo, which is the Go-like interpretation for C. Go was originally written in C before being rewritten in Go, but we're going to make sure we set cgo enabled off. We're going to copy our Go mod file over, and we're just going to do that with go dot sharp asterisk, and then we're going to just copy it into the file itself. Then we're going to run go mod download, and this will really download everything we need. Then what we're going to do is we're going to copy over our .go files, and we're going to copy over our .go files to the main thing. So now what we'll have is our go.mod and our go files itself, and that's all we really need for right now. Now let's take that base image that we're building, and so from base, we'll call this build, the new one. And what we're going to do is we're going to make sure we set the environment correctly. So we'll set the Go OS, the Go operating system we're building onto Linux, and we're going to run some complexer commands, but just know that we're going to mount this as a cache with the target being root dot cache slash I'm going to copy this in, make sure I don't make a spelling error, with the cache being for the Go build cache, which is up here. And then we're going to run go build o app. And so we're going to build this app now in the container. And then what we're going to do is we're going to take a new container from scratch, an Alpine container, so from a very lightweight container with very little in it as our binary container. We're going to install certificates. So this is not from cache. We're going to add CA certificates, very lightweight thing to download. We're going to set our work dir to root, which is, going all the way back. We're going to copy over from the build, from build, which is the previous container, slash source, to the main root that we're in right now. Now we're going to execute command /app. So I see that Steve is wondering, what is Docker being used for? Docker standardizes the way we're making this. So we know that if we're able to build the Docker container successfully, we'll be able to, if we're able to build the Docker container successfully, we'll always have an app to use. It's really critical because we're going to be using something called Docker Compose, which will let us run other apps side by side. So in our case, we're going to be using Postgres as a database. But in the future, you might want to use things like Redis or LocalStack, which mimics Amazon Web Services, or a litany of other things, or even have other apps talking to other apps. And that's all through Docker Compose. So as you can see, this is our file, and I've shared this in the chat, and it should still be posted for everyone to see. So let's take that out now. So let's make sure that this is running. We're going to put something new in our make file. We're going to just call it build. So if we go to our make file, we have this. Let's make just a build. And we're going to set Docker build kit to 1, meaning that we're going to use multiple stages in our build. We're going to build, tag it with -t as job tracker, and we're going to just provide it the Docker file here. So if I do make build with Docker running, it starts to build. It's going to download everything. So the useful thing about having a multi-stage build is it's going to cache our dependencies from run to run. So you won't need to re-download all your modules, just like on your computer. We're also going to create a make container, or we can say, call this even Docker run, and this is going to run the Docker container on its own. And so let's test out running this. If you see, we're specifying an environment variable port here. So while everything is running, and giving me errors, obviously, because life ain't easy. From build / source. Oh, I see. I made this the wrong one up here, so let's rerun this. So we're specifying a port here in our Docker run, and that's because maybe we want a dynamic port when we run this. So what I'm going to say is I'm going to say that port will be colon equal to os.get env, and what we're going to take in is our port. Then we're going to say, if for some reason port is empty, meaning that it wasn't there, we're just going to say port equals 8080. And then we're going to remove the 8080 here, make this %s. Then we're going to add funct.sprintf, essentially, so we can then dynamically assign a port. Cool. So our Docker container just finished building. And let's go and let's do make Docker run. And it runs it. And so now, even though the Go app itself isn't running, you can see it's not running. Let's try posting and using our Postman to see if our Docker container works. Post it, and we get something back. Get it, and we can view it. Delete it. Yes, we can. Get it. Get that error. Great. So everything's coming together, and actually we are on track right now. So the next step is really, how do we add a database? Well, the first thing we're going to do to get our database is going to use Docker Compose. So we're going to create another new file in our VS Code. Great. And so we're going to call this Docker Compose.yml or YAML. YAML is not a markup language, hence the name. The Docker Compose is something I'm going to copy in here, and I ask you all do the same. And we can plop it down in here. Great. And we can see that, let's go over it. So we have in a Docker Compose, we define each thing as services. The first service we have is our backend, which is what we've been working on in Go. We can build it from the Docker file that's located in the same directory, hence the dot. The image is job tracker, which you can see is what we can tag it, job tracker. The container, we're going to call it job tracker. Always restart it when the Docker Compose is run. Ports are going to be 8080, and environment's going to use port 8080 as well. And then we can set volume as app, and that's going to let us have a database. We're going to depend on and link DB. As well, we have an environment variable of Postgres host, which is called Postgres because it actually comes from our container name Postgres here. So the second service is the DB, and this is image of Postgres, which we're pulling from the Docker Hub repository of all the Docker images that are on Docker Hub. We're going to give it the default Postgres ports of 5432, always restart it, and as well pass it some environment variables. So talking about environment variables, we're going to probably want to define a .env file, and this is where we can put all our environment variables. So we'll just copy in some basic environment variables of host, user, password, name, and port, and as well our port for our own application. You can see all of this in the repository shared in the chat and will be in the link below of the video. Let's make sure we add our .env to our gitignore, because you do not want to release your env if it contains sensitive information, like we will do with a Google Cloud Platform as our database when we want to use the cloud. So the next thing will be loading this in our Go application, and that will mean importing another package once again. So we're going to want to do go get, and it's going to be Joho's go.env or .env, but for Go. So we'll do go get github.com/joho/go.env. I'll run this, even though I already have it, and you folks will see. So it's added to our go.mod file. You might have to download it. So the way that you can load this is pretty simple, and what we're going to do is we're going to just do error is going to be equal to go.env.load, and say if error is not equal to nil, just say, log.fail error loading.env file. Great. And so we'll make sure we bring in github.com/joho/go.env. And this takes a while to parse sometimes. I do prefer to use Golang. I do find it to work a bit faster for me in indexing once everything is all indexed. But we can see it's found, and we are able to use go.env easily. So the next thing is where we're really diverging in the application a bit. So all of these functions are going to now need to be changed, because these parts where we deal with the data are no longer going to be a map. So what we're going to do is we're going to delete apps from everywhere that it's done. We're going to comment out all of these so we know where to go back to and make the changes. Great. So right now we have some errors. So what we're going to need to do to solve that is, the first thing we're going to also want to do to use a database is bring in an object relational mapper. An object relational mapper will help us ensure that we can easily use the database without anything too big. So we're going to need to bring in GORM. So GORM can be easily brought in with go get gorm.io/gorm. You can see downloading gorm.io. GORM. I actually might need v2. I'm pretty sure. So gorm get. Nope, that's correct. Okay, gorm get. Ooh. Yeah, gorm get, and this will get us gorm. So with gorm ready to go, we're also going to bring that in. So we're going to bring in a few things also here. We're going to bring in gorm.io/gorm. We're going to bring in gorm.io/driver/Postgres, because we're using a Postgres database. Great. And so it's imported but not used. So let's get it used over here. So where we're loading everything up, let's do this. Let's quickly define a function for new DB. So let's say DB error is going to be new DB, and maybe let's take in a DB configuration file, and we'll call that configuration file config. We'll return a repository and error. Oh, sorry. And I don't know, I'm doing that. Okay. So new DB is not declared. Let's go down here. Func new DB, DB CFG config, and we're going to turn we are going to return a gorm.db and an error. Can it be done using pure SQL? Absolutely, and actually a lot of the time I would do pure SQL just because it's easy for me since I'm pretty familiar with SQL. But for a lot of people, it's easier to use an object relational mapper because it does the same thing. With Gorm, you can also use it to execute raw SQL. There is just the db.raw command, but as well you can use the raw command in conjunction with other commands. So maybe you want to use raw for some sort of query, but you need to use the models that are built in it. So it can be helpful, but we're going to just stick with some basic stuff. So we need to define this config that I just mentioned. And so config is going to be easily defined with type config struct. And let's just put in really everything we're going to need. So we are going to need to connect to our database a host, which is a string, a user, which is a string, password, which is a string, DB name, which is a string, and a port, which is a string. Cool. We're also going to just set our config pretty simply in our main.go by saying that our config, let's say db config, is going to be config of type. Then we're going to say our host will be os.getEnv, os.getEnv, Postgres underscore host. And what I'm going to do here is just to save myself a bit of time, and I suggest you folks do as well. You can just do control down, shift down, and we can do this. So we can just do user, password, DB name, port, host, user, password, DB name, or let's call this name, because what we did in the env, and port. So now we're going to be able to get all of these in our config. Let's show DB CFG, and we'll pass this over. So now we'll be able to create this config. So we still need to handle this creating of the new database. So in this function for new DB, what we'll do is we'll just simply make a Gorm connection. So what we need to do that is have the DB config URI, or the DB URI based on the config rather. And that's going to be sprintf and I'm just going to copy this in. Because to save everyone time, and it's already been public, so I recommend you copy it too. And so we're going to copy in that DB URI. Then we're going to say .db error is going to be gorm.open, and we're going to say it's going to be postgres.open DB URI. And because we imported, everything went away that we were importing. Let's see if it'll come back. Gorm.io. Oh, there you go. One came back. And then we have gorm.io / drivers / Postgres. And so that'll handle that. And now what we can say is if error is not nil, we're going to return nil error. And then if not, we're going to do db.auto-migrate. And this is going to migrate as many models as we want. So we're going to do our application model we want to migrate, and then we're going to return db nil. And so now we are creating a new DB with that application is going to be in it and auto-migrated. So if we make any changes, we'll always be able to have it. So now we have DB. But just because we have a DB, we need to be able to pass it to our handlers so we can actually get things done. So we're also going to make a new type there, and we're going to call it type server struct, and it's going to have a DB of gorm.db. And we're going to say that our server will be equal to server with a DB. So what's the point of this? Well, I'll show you. All of these functions over here that are now being called, we're going to append server to it. And that way, with the receiver of server, if I want to do something, I can now do s.db. So kind of like putting it in the function, but rather than changing the function itself, I'm giving it as an attribute of server. So server.getAppID. And so if I do that, now we need to add this to everything. So we'll make these all functions of our server. And we can even, if we wanted, add more abstraction and make DB its own layer. But let's stay away from that right now in the interest of time. Maybe we can follow that up in the next tutorial. So now we can do server to run all these functions. Now let's do this. For getAppID, we can do s.db.take. We can give it app, and then we can do app.id. So I'm just going to go to Gorm. You know, I use Gorm literally every day, and I still go to the docs. So I'm just going to go make sure we're using the right commands for getting the first thing. So retrieving a single object, take user. So let's say we have app. If we say that app is going to be an application with ID as ID, this will return us that app. Cannot use ID, and we just need to make sure we cast that. So I'm going to say ID 64, and then we're going to say ID is equal to int ID 64. By the way, we won't deal with it. Cool. So now we have an application. We'll be able to actually retrieve that directly. Same thing for creating one. Now we can also do s.db.create app here. All right, that's update. So let's do update. So if we want to update, we're going to use save, not update, because update is like for updating columns. We'll use save. Here we're going to do s.db.model. We're going to provide it the application model. We're going to do delete, but for delete, we'll specify the record with the primary key, and so we're just going to do .delete, and rather what we can do is do .delete, and then we can just do rec.id. Cool. And then our last one here is create app, and this is going to be s.db.create and app. So theoretically, We want this all to work perfectly with no errors. Form IO drivers, Postgres, make sure if there's any comments. Cool. This is called driver, not drivers. Cool. Let's bring in Gore IO driver Postgres here, which will be what we need. Maybe need to go get it. Great. And it's added. So it's saying can't find it, but I'm sure it'll find it in a second. We'll do go mod tidy in the meanwhile. And now it's probably time to see if this works, as all our errors have went away and we're now using a DB. So let's go to our make file once again, and let's add one last thing to run our Docker Compose. And that is going to be make up. And on up, we'll always build the container. So we'll just do up, build, and we'll run Docker Compose up. You don't need this dev shell thing, but it just empties your output into the shell, an empty shell. So we do make up. Moment of truth, we'll put it all together. We'll see if our Postgres is going to work and our whole database comes together nice and well. If this all works, we'll start building out a little front end so we can actually edit our app and use it from online. And I'll see if we have enough time to deploy it today. Maybe if you folks in chat have one preference, if you want to see me make a front end for it, or if you want to see me deploy it, let me know. I see we only have 45 minutes left. So we'll make that time count. Great. And so it's up and running, creating Postgres. An error, job trackers already used by container. We have to remove it. So we'll do Docker PS. So we're seeing we're already running job tracker from earlier. So we're going to just do Docker kill job tracker. And then we can run up again. Great, Postgres is up to date, creating job tracker, and it's done. Let's see if there's any errors with Docker Compose logs. Make sure everything connected smoothly. By viewing the logs, we can see, yep, database is up. Error loading .env file. So there's an error loading the .env, and that's probably because .env was not copied. So let's just do makeup once again. That's why it's important to check your logs. No one wants to. I've definitely deployed to the production server, and then you realize you had a mistake and you should have checked the logs in when you build. But it is what it is. Sometimes you have so much faith in yourself that you push things that are broken. Let's check the logs. Great. Postgres is still up. Error loading .env. But is that from us or from this run? I'm not too sure. Job tracker up to date. Let's just do Docker Compose restart. So restart everything in the Docker container. So no one wants to spend time restarting Postgres, restarting whatever. So a restart. We'll check the logs again. Loading.env file. Copy.env slash. Oh, my bad. So this is slash. That would be like putting it in the home directory. We actually need to put it in the current directory, which is /. Silly me, silly me. Right. Check the logs. And we see it's finally running well, as God intended, as the Lord Jesus intended himself. So let's go over to, let's open things. It might be a bit blurry because I have a wide monitor. And let's see if we can do things together. So create something. Looks like it, created this. Let's get it. We're able to retrieve it. Let's make a new posting. Let's go Google, software engineer, google.com. Yep, we got this job. Can check that out. Great. So now the moment of truth is this. So let's go and let's switch back to, let's end what's running here. Let's see if we can open a database connection. Select your database driver. I think we need to find maybe a Postgres driver. Oh, I already have Postgres. Is there a way to view it? I really don't use this, as you can tell. Open, select Postgres Connect. As you see, I really don't use this for checking it out. I usually use Goland. It's quite nice. SQL editor must have focus. See, who the hell knows what that does? Well, we can do this. What we'll do is we're gonna restart the container. So let's just do Docker compose restart, and we'll try and fetch this again. So if we tried this on our old app, we would never be able to fetch this because we didn't preload our data with anything. So now the container's restarted, we're getting internal server error. So maybe something didn't save because things are not working, as we can see. Unlucky, but we can still post internal server error. Let's check our logs. Nice, good logs. We can see invalid memory pointer, main go 100. Let's find where this error is at. Create app. No reference memory dereference. Maybe because Gorm had an issue connecting. Let's see. Panic recovered. Invalid memory. Main go 90. Get app by ID. Interesting. Sometimes these happen. Let's also make sure we just do db dot close, and let's make sure we defer that. So this is a kind of an asynchronous way to make sure we can close this. db dot enter no close. Probably built into Gorm itself. Okay, so why is this not connecting? That is a great question. A great question indeed. Initialize database could not connect. Connection refused. Interesting. Let's do Docker compose down. Make up. Why do we need these lines in Docker? Which lines in Docker are you referring to, Nam? So created. Let's try posting this again. Internal server error. Could not connect. Got error. Connection refused. Interesting. Docker PS. Let's take a look at this. We can see that Postgres is running at 5432. You know, sometimes you test things before and they still don't like to work with you. You know, that's how life is sometimes. Gorm open host. Failed to initialize. Database got error, failed to connect. So if we look at our files here, interesting. Our volume, we have dot, it should be linking from Alpine has been. So what we're doing there, it's a multi-stage Docker build. And so the reason we're doing that is because we want to utilize caching different layers to speed up our build process. Database was shut down. Database system's ready to accept connection. Try make up once again. And our Docker compose should be restart always. Sudo Docker compose down. So this will shut down everything and wipe it, remove it, make up. Things worked really well for 1 second, then we stopped it and it didn't work again. So that's how life likes to treat us sometimes. Great. Try and post something. Internal server error. Check out the logs. So the CA certificates is if we want to run HTTPS. Let's see. Error host Postgres, user Postgres, database Postgres, style error. Dial connection refused. Interesting, that's refusing our connection. This did not happen earlier. But, you know, it is what it is. We will debug this like good as software engineers do. Docker PS. So Have you opened Docker or maybe port binding? Yeah, I was testing this out right before, and it was all working. So I'm wondering what happened. And it did work, and then it kind of broke. So maybe I broke the Docker container somehow. I wouldn't know. When I go to make a new DB on this, we check. Let's do if we're not error checking here. If error is not equal to nil, do log.fatal error. That would help to know what the error is. Great. So after this, it should restart the containers. And now it seems to be connecting because now is nice. Send this post request. And we get it back. Okay, so it's working with us now. Send this post request and get it back. Okay. Let's do Docker compose stop. Docker compose start. And now we should be able to query this. I don't know what happened. It was really weird. I didn't even really change anything. Try getting this again, and we get it again. Magical, amazing. It all works. Cut out some of the error. I don't even know what I changed because I didn't change anything, but it worked in the end of the day. And we can see now we have persistent data. So we can add in a few more. We can put Facebook. Maybe we can just put engineer, facebook.com, and we can make that. Great. We can do Twitter. We can say network engineer, twitter.com. But you might be thinking, Alan, how am I supposed to remember these whack IDs? And that's a great question. So let's tackle that, knowing that we also are dealing with persistent data. So let's say you want to make changes to your app, right? So we have get app by ID, but no function to get all IDs. So the next thing we're going to do is let's make server, and we'll do get apps. It's going to take in that siege and context that we've grown to know and love. What we're going to do is we're going to just return everything. So we're going to say var apps is going to be a list of application. Then we're going to do s.db dot dot get. Let me just make sure I can do this. Go into these GORM docs. And what we're going to do is we're just going to we're going to use find. And so we're going to say, let's just say result is going to be dot find. We're going to pass it and apps. And it's going to find all the applications. It's going to take in result. We're going to say if result.error not equal to nil, we're going to see dot abort with status. We say status dot or http dot status internal server error. We'll also do log dot error f or log dot error, and we're going to do result dot error. I think it's rf log dot. No. All right, log dot print. Okay, cool. So now we can also do get all apps, and that we're adding a new endpoint now. We're going to restart it on live data. And so we can do router.get on/app s.get apps. We're going to do make up. So now we're creating a new endpoint for just /app getting, and it's going to get you back a list of all the apps. And we're going to need to do this one more time because we're going to need to return that as something. So we're going to need to do http.status OK. And we're going to return the apps itself. So we'll run makeup one more time. But here you see all from scratch, a place, persistent database, and everything. When you want to put this on the cloud, you just swap out the Postgres details for any cloud instance with your own, or you can even put this up on something like Amazon EC2 server. So it's running, recreating, cool. So now from Postman, send it, we can see we get a list of multiple jobs that we posted. We can put another one, of course, me, Coinbase, backend, SWE, intern, Coinbase, post that, and we get it back in our list of apps. And we get it back. Oh. But it's not, it's okay. We'll run this 3 times. And we'll get it back in our list of apps. One reason that we're doing this is we're making the ID random rather than something like UUID. If that's all working, are there any questions folks might have about using this? I might make a small change to this, drop the tables and restart. But do you have any questions, Nam, or any other people in our chat? I know there's a lot of you there right now watching this live. Does Gorm have indexing? Indexing on what? So you can use any of the indexes specified. You can specify specific indexes. But you can query based on like anything else. You can query based on different things like company, job position, last updated. You can use order. It is pretty fleshed out and is the most popular Go object relational mapper. So I'll just direct you to also. So there's Gorm.io. And so Gorm is the Go object relational mapper, I think is the name. And so an ORM is just a way for you to manage your objects, right? So it really translates to SQL itself. And you can actually see the SQL that's running with the dry run command or the debug command. And so you can see how long every command is taking, what the actual SQL being executed is. Sometimes it's exactly what you expect, and sometimes it's a bit different for its own reasons, be it the way it's implemented, or even it's optimizing the query based on the data type. So let's make a change to our data model of applications. We'll make this string. Call it UUID. Over here, we'll just need to use ID is going to be c.param ID. Over here, we're going to use UUID.new to set our ID. We're going to take out math.rand, and it actually is bringing. So you're going to need to do go get github.com/google/UUID. And so because UUIDs have such a low chance of repeating, like it's astronomically low, we can actually use UUIDs to make our program stronger than just random numbers. And so we'll see how this looks like, and we'll see how we can get everything, and we'll see how GORM is going to migrate with its auto migrate feature. Honestly, not 100% sure how it'll go, but auto migrate in GORM has been pretty strong in my experience. But sometimes you'll need to just drop the tables. And let's get our apps. So we'll see we fetch our apps, and we don't have any ID on these ones because they do not actually have the ID, which is unlucky. So, but if we create a new one, we post Coinbase frontend, we can see we get a UUID. We can get a specific one. It's going to return that for some reason. And as well, we can get app by ID. Let's get application with that. And as well, we can get all of our applications. So you can see this one has the ID in it here. So what we might want to do at this point is drop the tables. So we'll open up this. We'll call this localhost. Connect using server and port localhost database Postgres database. Will just be Postgres test connection successful, save connection. So now we can actually go into it, which will be a bit nicer. And we can go into our Postgres database here, enter the schema, can see the tables of applications, and we can actually just drop the table. I assume. So you can do something like, drop table applications. I don't know. Not the biggest expert with VS Code and all its tooling. So if anyone knows how to drop the table from here, generate insert query, describe table, add name. Maybe it's more for people who have Postgres Connect. Oh, this should not be a SQL. Well, I might have broken that. But we'll go here. localhost 8080 or 5432 slash Postgres. Great. And now if we run this, you get nothing back, which is exactly what we wanted. So let's rerun our app. Cool. So we'll run this. Awesome. Cool. And now we can go, we can post front end, we'll get back end. We can make Google posting. Great. And then we can get them all. And we can get them all. All right. Let's go into that SQL again. SQL tools, tables, nothing here. Let's go Docker. Go Docker restart job tracker because it should auto migrate that model. Oh yeah, okay, we see applications, UUID. So we probably want to specify a primary key in here so we can actually go here and we can go GORM primary key. Yeah, capital K. Great. Let's run make up. Let's also drop that table. So now we see we have no table. We're going to rebuild, rerun. We're going to get that table back with the auto migration. Cool, recreating. Done. We run this. We can see applications is back. And they're not labeled the primary key, but let's post this. Get it. And we can see Facebook as a data intern. We can see. Let's get the Google posting in there. Let's get a Coinbase posting in there. Front end posting, great. get all of them, and we can see that now we have all these UUIDs, companies, links, and what's happening. So now we just have a simple job board, links, and we can see places to do it where we want to put our things. So the last thing we'll add to this to give us a bit more of a job tracking aspect is just a status. And so we have a status over here. And so let's say we take some of these job postings. Let's take this ID. We'll put it status applied. Put in a UUID, get status applied. And now we can see that, oh, or did not. Error application relation applications does not exist. So let's start from, okay, well, should have been working now. I think there was some old errors. Update applications where is not set. So we need to make sure that when we're doing the save app, it's probably because the primary key is not being specified correctly in our definition of the program. So I'm just going to check out. I see. It should be like this. So let's do this. Let's make up. It's a space, not a semicolon. Classic error. See it get created live. Says it's up. We do this, but we don't get any update yet. So all I need to do is to drop the table and let it get recreated with GORM primary key to define it as the primary key. Make sure we spelled everything right. Great, let's make up. I have to drop in these tables. Great, let's refresh this. Let's see. We need to do a and let's see. We can see we have applications with a UUID as the primary key now, finally. So now let's close this off. Let's go to Postman. Let's post a few jobs. Let's post our Coinbase front end, our Coinbase back end, Facebook back end, Great. Google backend, because these are the only jobs that matter. Check them all out. We see them all made. Let's apply to Google. Let's mark that as applied. Great. Let's get it. And we see it removed everything else, but it's there. Why does it do that? Well, sometimes when things are given a value but they're not nil, it will update it like that. So let's try and debug this one last thing. So we see we're doing .save. Let's try dot updates. Ouch, let's delete that one. Make sure we can delete it via string. Wait for the container to recreate. Deleted, app deleted. Get it? It's still there. Lord hates us. Let's try updating this Facebook one. Applied. And we can see Facebook has applied. Now delete isn't working with us because, sometimes they don't like to delete. So what we're going to do is let's try a different way of deleting. And this is the thing with using an ORM, right? It's a bit weird. But let's just try delete. Let's just give it where it's UID is equal to that. Make up, and if this works, if we can delete our last thing, we'll call it a day, and we'll save my wonderful front-end work for our next session where we can build on this. And the great thing about having Docker containers is they can just be pulled by anyone. Super fantastic for saying, hey, I made this app, check it out. No need to install anything or prerequisites. You can just run a container. So we'll delete on app, says it's deleted. Try and get this one. And it's gone. Perfect. So now we can update, we can post, we can do whatever we want, and we have a working, functioning app. Almost a full stack, missing a front end because we may have run out of time a little bit, but it fully works with Postgres. So make sure you come to our next session where you will learn how not only to post, but how to do a variety of other functions on your front end. And so, as you can see, we implemented a simple HTTP REST API with a few endpoints to post, put, delete, get, and get by ID, a very standard CRUD interface with simple functions, working with Postman, strongly typed, running blazingly fast in Go, using Docker and Docker Compose for building with a makefile. So with a project like this, we're going to do git add -a, git commit -m, backend and db, git push, origin main. Wonderful. All right, I'm going to delete these two things. Cool beans. All right, so that's it. I'm going to push this. Docker isn't something you need to learn. It's really just about using the files and knowing the commands. I understand I'm biased. I've been using it for a while. But that really allows for a full stack app to be made with a great backend front end and with a little HTML on the front end. You can leverage that entire backend API. So I'll take this down. I'm going to Docker RM this. No idea what the SQL tools file links to. I guess this SQL tools. Disconnect. Still doesn't want to leave. All right. Well, I guess it's going to push. Git push origin name. All right. So if you folks have any questions, you can reach me on the GDSC server at any time. It was fun coding a bit today with you folks, running into issues as software engineers do. But, it's a part of the learning process, and I hope you folks can have fun on your own learning journey. You can add me on LinkedIn. Feel free to message me on Discord, LinkedIn, Instagram, whatever floats your boat. Check out radar.coffee, my startup, and I'm sure I'll talk to you folks again next time. Thanks for tuning in, and especially for the folks watching this later, I hope you stayed till the end and enjoyed. Bye now.